Hi there, I'm Yen, and in this video, I'm going to show you 9 ways that you can incorporate text and literacy into the STEM activities that your students are doing. So in this video, I'm experimenting with PowerPoint's translational services. And so you'll see my words written down at the bottom of the screen. In this video, I'm going to talk about when to bring books into an investigation, 9 ways to use books for minds-on experiences. And what I mean by that is we also have hands-on experiences when it comes to teaching STEM, but oftentimes they're not rigorous or aligned to the NGSS standards. Today, I'm going to show you how to actually use books so that it engages kids' minds as well as their hands in doing these kinds of investigations. And then finally, I'm going to talk about how literacy aligns to the next generation science standards cross-cutting concepts. So first I want to start with having you think about how we naturally learn. Say, for example, you're faced with a problem or a question. For instance, the toilet is clogged. So first, you go for the plunger and try and solve the problem on your own. But then when the toilet overflows after plunging and flushing, you've now evaluated the results and realized that you need a different tactic. So you go to other sources and research the information, maybe through YouTube, WikiHow, blogs. Perhaps you call your Aunt Jan to find the answers. From that information, you apply the answers to the problem. Then you repeat the evaluation to see if the toilet now works, and if it doesn't, you go back until you get the desired result. Now, this part here about going to other sources is right where you pull in texts and other books. This happens right after kids start the initial investigation. Why? Because what you're actually trying to do is align your students' learning experiences and activities with how they instinctively learn. When STEM investigations parallel the learning process, kids become more engaged and STEM becomes a lot easier to learn. You're plugging into natural learning instinct. And here's what I mean by that. Remember way back when about Constructivism? It's that learning theory that states that knowledge is constructed by individuals through their experiences and interactions with the world. What this means is that we construct new knowledge by building or hooking it on top of what we already know, which in this case I'm going to call prior knowledge. This is the hook that makes things relevant for your kids. It's going to always be the foundation to build your STEM experiences on. Without this foundation, if you introduce new knowledge, like texts or new vocabulary to your kids, for instance, it may not stick because it's not relevant or tied to what they already know. And because science is already seemingly abstract in some ways, building on prior knowledge is one of the best ways for teaching STEM because it gives you a bridge between your students' prior knowledge and the new science or disciplinary language. Kids need to have meaning first, a hook first that they can relate to before you introduce something new. Finally, as you continue to build on top of things, Next Generation Science Standards provides a map so that when kids graduate high school, they have strong foundational knowledge in STEM to support any of their future endeavors. So in this video, the takeaway message is introduce books and texts after the initial experience or investigation. So going back to this typical learning experience, a big part of the learning that I'm talking about is that moment when we go to other sources to find the answers. And there's a specific term for that. It's called resourcing. Formally, resourcing is the synthesis of multiple sources of information to answer a question, solve a problem, and/or communicate understanding. So remember that clogged toilet and going to YouTube, WikiHow, and Aunt Jan to find the answers? You're resourcing by going to multiple sources of information, then applying bits of that info that are relevant toward your problem. Resourcing is where you bring in texts, and that's going to help kids if they're redesigning their prototypes in engineering, when they're explaining what they did and what they found in an investigation, reflecting on their experiments, and when forming their conclusions. Now, with that in mind, if you take a look at the engineering cycle, there's 2 points during an engineering challenge where you can incorporate books. The first point is right after kids have, say for instance, flown their first plane prototypes if it's an airplane challenge, and they're ready to redesign their planes and their builds. The second point is at the end of the challenge, when they're working on their conclusions. So let's talk about this first way. During a challenge, kids build something to solve a problem. In my example, they're creating a paper airplane to see which one flies the furthest. They build the prototype and test it. In their tests, they see that the plane may not have flown as far as they would have liked. So you're going to give them a chance to reflect and redesign. So maybe at this point, you bring in books on airplanes so that kids get multiple ideas of how to build them as a resource. Then you want to encourage your kids to take these resources, these books, their previous design, the designs of their fellow students, and then redesign and improve upon their previous prototype. You've now gotten them to synthesize the information, and that synthesis hits all kinds of ELA and NGSS standards in doing so. Then, if you ask kids to measure how far their planes flew, how high they went, how heavy their planes are, now you've also hit the math standards as well. The second way that we talk about incorporating literacy is after a challenge or an investigation. So after you've flown the plane, you can bring in books to augment vocabulary or to help kids think more deeply on their investigation or seeing their investigation in a different way. For instance, when it comes time for kids to explain what they did, ask them what forces acted on the plane in the air. Here's the minds-on part of the thinking that I was talking about. Then have them look at a book and then apply what they've learned. This book by Boothroyd is a great augmentation or a great supplement to the airplane activity. In way 3, you can use books to help with investigations and with identifying and describing the things that are happening. For instance, say you have students keep a weather journal. You can use a book like this one to help kids identify what clouds are in the sky. Then when kids have identified the clouds, ask them, what features helped you identify the clouds? Incidentally, all of these books are going to be referenced in the comments of the video section, so no need to be scribbling madly as I bring them all up. By having kids think about and describe the cloud features that they see and use in identification, you're giving them opportunities to use language to communicate, observe, and create an argument for what they've classified their clouds into, whether it's one type or another. Again, this not only hits next generation science standards, but it also hits the ELA anchor standards as well. Which brings me to way number 4, which is about using books as identification guides to help students catalog items. And I love using identification guides. There's guides for flowers, plants, bugs, weeds, and even better, you can have kids make identification guides, which is powerful learning right there. Using guides help kids actively engage in ways to see and organize categories, patterns, and details. All of these things are touched upon in ELA and Math Common Core, as well as the next generation science standards. Like I said, one other idea could be that you have your kids collect different seeds from their kitchen, from outside, from the store, and then have them key out what they are. Conversely, you can have the whole class create a key where everybody's seeds are classified within that guide. Now, way number 5 addresses inclusivity and identity by helping your kids position themselves as scientists, mathematicians, and engineers. We help kids see STEM as a possibility in their careers by giving them spaces to be these things and to try them on. Periodically asking the question, how are you being a scientist or an engineer or a mathematician, at the end of their investigations is a wonderful reflection piece that gets at shaping positive identities. Plus, it makes them reflect on their work and connect it to how STEM is actually done. There are 3 books I recommend for this. The books by Andrea Beaty are amazing, and she's written quite a few to suit your needs. So Ada Twist Scientist and Rosie Revere Engineer are probably 2 of my favorite classics. Then for kindergarten and first grade, I suggest the book, What is a Scientist? By Barbara Lehn. This is a great reflection question, how are you being a scientist? Because kids need to read the book and distill out what qualities of a scientist or an engineer are before they apply these things to their own actions. In doing so, you're also giving kids opportunities to identify with these STEM careers and apply information from books to the application of what they're actually doing. So the first 5 ways that I've given you can incorporate literacy into STEM as resources that kids use during and after a STEM activity. Now, I want to talk about recontextualizing. Recontextualizing means the translation and application of information from one modality to another. In other words, when you provide opportunities for your students to move information from one modality, say writing, recording, video, blog, hands-on applications, and so on, to another form, you're actually engaging them in very, very deep learning. Recontextualization forces students to understand and distill meaning first from the first modality before they can actually translate it and think about it and how it translates into a different modality. So for instance, writing to drawing, drawing to some form of interaction. Interaction, like what they did in a hands-on activity, and how they translate that to a video, or a video that they've watched and then writing about it. These are all great ways to recontextualize, and I'm going to talk about some specific ways in a minute. So way number 6 is a powerful example when you ask students to take a written procedure and translate it into drawings with labels. For instance, here's a recipe for oobleck taken from livescience.com. You can have kids go through the procedure. Then, before they're allowed to do the lab, they need to draw out what they will actually be doing. It might look something like this. You can even have kids explain the drawing to you so that they can show you that they've actually know what they've done and what they've drawn. This is a great strategy for kids who may have trouble following directions. It also helps them think about directions, represent directions, and then talk about the directions before they do the lab. Of course, this may not work with all grades, but here you can see that this first grader was able to draw the procedures for oobleck pretty well. Plus, having the materials present and displayed outside is really going to help with this. Way number 7. Have kids create PowerPoint or Google slide presentations like this one, or use a service like Seesaw to have them do a quick video that summarizes what they're learning to an audience like the adults in their lives. You can have them do videos based on prompts as, what is your main takeaway? Tell us what you did. Give us one thing that you learned. Maybe explain what push is or what it means, or what advice would you give another first grader when they do this activity? These kinds of prompts and this kind of video activity helps kids verbalize their actions, but it also positions them as an authority because now they get to be an expert at what they're doing. Maybe when you have kids write down about the weather, they do a mock news weather report, complete with prompts to dress for the weather, and a handheld microphone prop as they're reporting to the news. Here, you can see an example of a TV station that will actually let your kids be filmed when they're visiting the station. Way number 8, the explaining piece of the I5Es closely integrates with expository or informational essay structure. And for those of you that are not familiar with the I5Es, this is actually an instructional model that we use in order to build lesson plans for STEM. And I'm going to include some links in the blog if you're interested in learning more about that instructional model. But I'm going to go back and talk about how explaining integrates with expository essays. So take a look at the grade for informational pillar, or also called the expository pillar. Notice you can actually easily bring STEM into an expository or informational essay. For instance, when you look at the structure here, you've got your intro, which is really about the problem or question that was addressed in the STEM investigation. The main idea is the first claim or inference that a student has about their study. Evidence comes from the data that they've gathered. This is where books can come in handy. Evidence can also be excerpts and quotes from books that support the student's claim. Again, this part is kind of a synthesis between what kids did hands-on and what they've read. And then in this kind of form, this kind of recontextualization, you're really turning minds on. Then finally, the conclusion is also similar to a conclusion in an investigation. The slight tweak in an essay is that it's about what this investigation means, also as well as suggestions or questions that they might have about the next investigations that they'd want to do about the topic. So a simple way of integrating literacy into STEM is by having kids write about what they actually do in STEM. Now, the last technique is more of an instructional scaffold that you can use in all the different activities that I've shown you. I'm sharing it here because it can really help students organize their ideas in terms of data and observations versus inference and conclusions. So technique number 9 is about T-charts. And if you followed our blog or taken one of our classes, you'll know that T-charts are one of my most favorite ways for getting students to write down information and data. While you can grab free copies of our T-chart templates in the STEAM Cafe resource library, you can also have kids divide a sheet of paper in half, hot dog style. On the left side, kids write down facts, evidence, and observation. When you incorporate texts, have kids record evidence, vocabulary statements, facts, definitions that they've gathered from the reading on the left side. Then on the right side, have them connect and apply it to what they're doing in their investigations. Or have them interpret and infer meaning from these facts to the question of what does it mean? For example, say a student is pursuing the question of what forces are acting on your paper plane. And they read, a push moves something away from a force, from their book. They should write that down on the left side of their chart, right? This is a fact that was covered in the book that they read. Then on the right side, for what this means, what this infers, or how this applies to their investigation, they might write something like, I push on my plane to get it to move away from me. So you can have students use a T-chart first to scaffold the information that they write in an essay or a video. In fact, you can use a T-chart in almost any one of the 8 different ways. This is 9, the 8 different ways that I've shown you in the video as a scaffold to get them to the next step. Now, while this is the last way I talk about in this video, in next week's video, I'm going to start with T-charts to introduce you to ways that you can investigate texts using the science and engineering practices. Now, speaking of NGSS, when we look at the 7 cross-cutting concepts, you can view them as a way of talking about the data that kids find or discover. So you can use cross-cutting concepts to help students interpret and explain what they see. Books may help students understand abstract concepts that are demonstrated in the investigation. For instance, in paper airplanes, kids can talk about the forces in terms of structure and function. They can draw and model these forces as they act upon their plane by asking them to use a diagram. Maybe as they investigate, you can ask, explain what patterns you see. Or if you want to address math, you can ask, how much, how far, how long, what would you use to measure this? Cross-cutting concepts can be a springboard to help kids look at and talk about the STEM that they're doing. So this week, I shared with you ways to help you use text to support and refine your students' investigations. In a nutshell, I'm talking about how to help your students view books as tools and resources. Next week, I'm going to show you how you can apply the science and engineering practices to conduct investigations about the text itself. Thank you so much for watching. And if you like these videos, please subscribe to our channel and check out our links in the video's description for the references to this presentation. Also, if you'd like to support our work, please visit our Patreon page and see what we've been up to. We would love to have you as a patron. Stay tuned and see you next week. Bye now.